The Conceptual Scenarios section of the review provides a good example of when I would give you some type of study design and you would have to pull out what the independent variable is, the dependent variable, classify the types of data each of those represent based on the context of the research scenario. And then you also would practice some hypothesis testing by composing your null and or research hypotheses and then creating some hypothetical situations if we had an a priori level of confidence in alpha, and then how might we estimate a p-value or interpret a given p-value based on those constraints. So for our example here, you are interested in investigating the effects of different mouth rinsing solutions on running performance in collegiate male track athletes. You collect a random sample of 18 athletes and assign 6 athletes a carbohydrate solution, 6 athletes a caffeine solution, and 6 athletes a solution with both carbohydrates and caffeine. A baseline measurement is taken for a 200-meter run time in seconds. Each athlete consumes their assigned beverage, then completes another 200-meter run 20 minutes later. The differences between the baseline run time and post-solution run times are recorded as a measure of the change in running performance. In other words, if a post-solution runtime subtracted from a baseline runtime results in a positive value, that means the solution actually slowed the person down because it would be a greater post-solution runtime than baseline. And then for the flip side, if we had a faster run post-solution compared to baseline, we would get a negative value indicating that time was shaved off of the run. Okay, we're not actually working with any values here, but just so you have an idea of what type of values we would be assessing. So, what is the independent variable or variables? Well, in this case, we only have one independent variable, and that is the different mouth rinsing solutions, because that is the variable that we are directly manipulating in our design. So, types of mouth rinsing solutions, and I'll put this in red. The type of data this represents is nominal because we have 3 categories that we have assigned people into, or 3 different manipulations that we're applying. So we have the carbohydrate solution, the caffeine solution, and the carbohydrate and caffeine solution. The dependent variable is what we are actually measuring. So this would be the 200-meter runtime, or runtime also works. The type of data these represent would be ratio. Well, I would actually accept 2 answers for this question. So if you put ratio in reference to the time being collected in seconds, we do have a 0 starting point for time. We could also classify this as interval data, though, because we noted that we would be recording the differences between post and baseline run times. So because there is a possibility that there is no change between the pre and post solution run, right, which would result in a value of 0, because that's a possibility, that means there could be both positive differences between our runtimes as well as negative differences, in which case we would have an interval type value or type of data. For number 15, what hypothesis would be statistically tested for this study? We're identifying the technical name of the hypothesis and then also writing it out in terms of the variables given. So the hypothesis that we statistically test for any type of analysis is the null hypothesis. And if we write this in terms of the variables given, we might have something that looks like there is no significant effect of the type of mouth rinsing solution consumed on running performance. There are several ways you could word this. Instead of running performance, you could put on 200 meter runtime. You could say there's no significant difference between pre and post solution runtimes, right? So there's a lot of different ways you could phrase this, but as long as you are pointing to the fact that there is no significant effect, then you're pretty much on the right track. Okay. If you determine the estimated p-value for the difference between the group means as p is less than 0.10, in this case, what is your alpha level? So recall that whenever we estimate a p-value, we are saying that the estimation part is p greater than or less than a certain alpha value. So the value that's listed after this greater than or less than operation is going to be the a priori alpha that you have already chosen. So in this case, alpha would be equal to 0.10. And our level of confidence is going to be 1 minus alpha, which is 0.9. Or when we refer to our level of confidence, we list that as a percentage. So we could say we also have a 90% level of confidence with a 0.10 probability of a type 1 error alpha. The appropriate interpretation of this p-value then, if we have a p-value less than the alpha we kind of predetermined with our study design, that means we reject the null hypothesis. And when we reject the null hypothesis, we accept the alternate hypothesis or our experimental hypothesis, which would argue that there is a significant effect of the type of mouth rinsing solution consumed on running performance. Okay. Other topics that were related to these questions was when we did our calculations for our confidence intervals. So sometimes I might actually give you a mean and standard deviation value within the research scenario, and then if I had asked you to calculate a confidence interval based on your alpha and level of confidence value, then you would look at your intervals. If there was overlap in the intervals, there's no significant difference between the group means. If there was no overlap between your intervals, then that would indicate there's a significant difference between your group means, or you have a significant effect. In our next video, we'll be going over our calculation section of the review.